Hey, Jenna, I'm gonna let Tim in.
Okay, sounds good.
There's two other people look like they're waiting. Actually, looks like there's three, but I'll let Tim in since he's one of our guys.
Sounds good. Hello and welcome everyone. We're going to get started in about 2 minutes. I've included all of the links for the workshop slides, creating an IBM Cloud account, the GitHub repo for the workshop, the link to access your OpenShift clusters, and the lab key all in the chat. So if you want to take a second to take a look at those, they will be available for the entirety of the workshop. If you have any questions, feel free to post in the chat and we can answer any of your questions from there as well. And if you're just joining, go ahead and share in the chat where you're joining from today. Very cool. It looks like we have a couple people from Austin joining, Nashville, New York. Do you have a good tuna melt today? You know what? I actually got a tuna salad today and I haven't eaten it yet. I had one yesterday though, and it was okay. So we'll see. I'm hoping to be amazed by the one I got today. Okay. All right. Thank you all very much for joining us today. Today is part 2 of our OpenShift 101 series, where you will learn the basics of Red Hat OpenShift on IBM Cloud. If you would like to share on social media, give any feedback, share any ideas, let us know how you feel about the series that we had yesterday and today. what you're looking forward to in the next events. Here's some social tags you can use to share on any of your social platforms. So for those of you who were here yesterday, I see a lot of you rejoining from yesterday. If you weren't here yesterday, please take a moment to answer some questions about yourself so we can all get to know you a little better. So your name and your title and company, or maybe a program or university you're joining from, where you're from or where you're currently quarantining and joining from. Something you love, and a quirk. So something that's uniquely weird or different about you. I will go first. So for all of you that are joining again yesterday, welcome, welcome back. And for all of you that this is your first time joining, welcome as well. Great to meet you. My name is Jenna. I'm a developer advocate at IBM. I am currently joining from Western New York, where I'm at my parents' right now, originally from Detroit. I moved to San Francisco to attend a coding boot camp. I got really active in hackathons and workshops, which is where I discovered IBM. Got really excited, decided to apply for apprenticeships, and then found myself joining IBM in Austin, where Nigel currently is as well, through an apprenticeship program. And then I recently joined the New York team with Nigel in developer advocacy. So now we get to do all this cool cloud API stuff, blockchain, machine learning, containers, and really add new cool technologies to our bag of tricks. So something I love is really good tutorials, really fun and interesting content. Anything that I can build a fun project with and add to GitHub is always a plus. A quirk, something that's uniquely different about me. Clayton already knows this. So I have an obsession with tuna. I didn't have a tuna melt today, but I will have a tuna salad later. It's kind of a sickness of mine, but I haven't gotten sick of it yet. Maybe I will one day, but until that day, I'll keep eating them. I'm going to hand things over to Nigel so he can introduce himself to you, and he will be taking you on our OpenShift journey today, part 2 of our series.
Hey, yo, as Jenna said, my name's Nigel. I'm originally from South Carolina. I now live in Austin. I am a developer advocate for IBM on the North America East team, which is based out of New York City, but I live in Austin. I focus primarily on cloud native technologies like containers and Kubernetes and OpenShift, which is why we're here today. I got my start with containers working in high performance computing, figuring out how to containerize applications that run on supercomputers, and then seeing the performance models of how containerizing affected the research that folks were doing with supercomputers. A quirk about me is that I am really interested in how things work. So I like to take apart and put things back together, do a lot of my own repairs at home, and yeah, build the little things with single board computers. So that said, is there anything else we need to cover before we get started, Jenna? I'm not sure if you're talking, Jenna.
My bad. Yeah, so I just reposted all of the links that you'll need from yesterday to, if you want to work through the workshop with Nigel today. If you don't already have an IBM Cloud account, this is the link that you would use to do that. Again, this is in the chat as well, so you can access that there. You will be creating an IBM Cloud free light tier account. This is what the sign up will look like for that. And then if you want to follow along or access the workshop at home later, this is the link for that, also in the chat as well. So Nigel, you can feel free to take it away. You are muted, just FYI.
Thank you. If you were with us yesterday, then you should have a dashboard similar to what I'm showing here for the cluster that was provisioned for you. And just a quick recap of what we went over last time. And this will give, oops, over here. Always takes a second to get my screen set up. But a quick recap of what we went over yesterday. So we started with talking about what source to image was, which was an open source project that's been developed by Red Hat to help us containerize our applications by pointing our source code to a few pre-configured builder images that allow our applications to be containerized and deployed to OpenShift with minimal intervention from us. All we did was point our builder images to our GitHub repo and told it what folders it should run the application from, and then our application was deployed, a route was created, and we could access that route. And that's pretty much what we did in exercise 1. And then after we did that, because we forked a repo that was already existing, or because we deployed from a repo that was already existing, and we wanted to make sure that any changes that we made to it would reflect in the deployed application, we set up GitHub webhooks. So what that allowed us to do was fork the repository, the original application repository, and make some changes to our repository, and then see those changes reflected on our live running version of the app. And after we did that, I think that was everything in exercise 1, that's right. In exercise 2, we talked about logging and monitoring. So we went inside of our pods, we looked at the logs that were present for the application that was running. We looked at the processes inside of the application. We looked at our event monitoring, and then we went over to our metrics and dashboards. So one cool thing about OpenShift is that it is Kubernetes, but it has a lot of other projects included with it to make it more production ready, so that day 1 you can run all of your applications, as opposed to deploying to Kubernetes or installing Kubernetes. There's still a lot of work that you have to do to be able to make it usable. It's not quite there yet. It's the analogy that Red Hat likes to use is that Kubernetes is an engine and OpenShift is a car that runs on that engine. So all of the trappings around the vehicle, that's what we're getting with OpenShift. And one of those things that you get is Grafana. It's another open source project, and that allows us to see really pretty dashboards about how our application is doing. And so we simulated a load, and we saw the uptick on the CPU usage for our application at the time that the load started happening. We talked a little bit about Prometheus and Alert Manager, which is how the metrics we're getting from our hardware to our to Grafana, and then the Alert Manager for being able to set up these custom alerts for any events that might take place. And where we stopped was getting to scaling our application. So just want to check everyone with us so far. Are we all right? Are we good to keep going? You want to give me a thumbs up or a +1 in the chat or something like that? Let me know I'm not just here by myself. All right, great. Clayton, good to see you back again. Thumbs up. Thanks, Evan. All right, let's go ahead and truck along. So I trust that, thank you, Reggie. I trust that we have our dashboards here. I'm gonna work off of this side. Scaling, here we go. So the main concept that we want to talk about here is auto scaling. So when we talk about like our cloud native applications, we want to make sure that we're set up for something called elasticity. We want to make sure that when our application is getting hit hard, when there's a lot of traffic coming to it, that we have enough resources to be able to handle those loads coming in. And then whenever there's no need for there to be extra versions of our application running, that it scales back down. So this ability to scale up and scale down based on the load is one of the features that make OpenShift really cool to use. And we're going to do that. We're going to do that with what's called horizontal scaling. And what horizontal scaling means is that we have a pod that's running our application, and that pod can only accept so much traffic. And so we want to copy that pod and make other pods that can help spread out the traffic. It's horizontal because they're all the same thing that are just making more copies of the application to be running. So let's see. In this exercise, we'll leverage the metrics we observed in the previous step to automatically scale our UI application in response to load. So the first thing we need to do is set up resource limits. So we want to get it to a place to know when it's appropriate for it to scale up our application. And we're going to do that by jumping over to our administrator view. We're going to go into our workloads and our deployments, and we see this node STI OpenShift deployment. We're going to have a look at that. We're going to go to our actions and edit this deployment. And what we get here is some YAML that shows up, and we're going to manipulate a few lines of the YAML. So we're going to go down to line 44 here. Oops, what have I done? Reload. Okay, there we go. Line 44. Okay. And we're gonna be very careful because YAML is particular about spacing. And if we mess this up, it'll be very obvious and uncomfortable. So that did not paste in properly. This was at this level, I believe. Actually, let me just, okay, under ports. If I take that line out and just go to the beginning, then maybe the spacing would be right. No, under ports. And then, not exciting. Are there any questions while I do this? Okay, I'm gonna try to get that fixed in the documentation so that we don't have to do that every time. But we get a green check mark here. That means that our YAML is valid. If, for example, we had broken YAML, then it wouldn't allow us to save there. So you know that you've done it right if you just get that green check mark there. Oops. Save it again. Okay, we're good. So we're setting limits on each pod that it can only be hit this hard before it needs to scale up some more pods. And what was the next thing? So we hit save and reload to see the new version, which we did. And then we want to go check out our events. So if we go to our deployment configs, no, deployments, I didn't make a deployment config here. And events, we'll see about a minute ago. Wait, oh, that's not correct. 1 second. I didn't make a deployment config there. Okay. Well, we should see. Let me go check out. I didn't deploy with a deployment config before, and perhaps that's why we're not seeing it here. But it's okay. No cause for concern. We're gonna, we do have 2 minutes ago, new set available events. All right. Okay. Let's enable our auto scaler. So what we want to do is go down to our workloads. We're going to look at our horizontal pod auto scalers, and we want to create one. Now, we've got some YAML in here to replace what's already there. So I'm going to put that in. So it's called patient HPA and our namespace example health. And then we're gonna get everything there should be correct. And we're gonna create that. So our minimum replicas are 1. So at no point in time do we want the replicas for our image to go down. And these replicas are how many pods are running at the same time. So at no point do we want that to go below 1. And then we're gonna set our max at 10. We shouldn't need more than 10 to handle whatever workloads come in to our application. So I'm gonna go ahead and create that. And the scale target is this deployment issue UI, but I think that might not be good. Let me look and see. Yeah, I think I might need to update this. Actions, edits. This was made for a different version. Ours is called actually, let me just delete this one and we're going to redo it the right way. So I deleted that autoscaler. We're going to create a new one. And I'm going to paste in again what we had before, except this time we're going to make sure that we're targeting the right. So node. Deployments. Yeah, this copy is the text. Node SI OpenShift copy. Cool. Create. And it's targeting this deployment. So when I click to that deployment, it comes up properly what it should be instead of the one that was already in the copy. So Jenny, can we make a note to update that in the text, please? Okay. Now that we've got that done, we want to enable it. Excuse me, we want to see if it's working. So if we go back to our developer view, we've got one pod running right now. I'm gonna bring back up our Cloud Shell, what we had before, to be able to simulate a load on our application. So I need to grab this link here. I'm gonna need at some point, not right now, make sure that app is still up and running. Yep, OpenShift Web Console, awesome example health. That was the change that we made. Okay, and then, oh, there is a load already hitting it because we see these other pods are spinning up already without me even hitting it again. So let me go look at our load. I'm gonna go over to our admin view and have a look at our dashboard and see what's going on in that workspace. But our autoscaler is working because we saw more pods spinning up by themselves without me having to push the up button, which you can do if you need to. So we want to look at our compute resources. Okay, we want to go look at our namespace for example health. Okay, and we got a huge spike in usage there. We've got one pod. Oh wait, oh we don't. We have several pods that are up and running. Look at all of these pods that are already there. Okay. Now if I'm gonna jump back and look at our topology here. We've got 3 pods running. Now what, if I go back and look at our admin view and then at our workloads deployments, this is the deployment that we have running. Right now there are 10 pods up, which is interesting because we don't need 10, which means I must have misconfigured something that it automatically spun up 10. So what I think happened is that in this deployment, we look at our one. Oh, it's automatically set to 10 replicas. Why? That's not right. Okay. Okay. I will troubleshoot this later, but it did scale up when we made that change. Now, if I bring it down, bring it down to 1 pod, which it should be happy to stay at without a huge load on the server. It keeps jumping up again. I'm wondering if there were other people hitting it. Why don't I change the route and like see if that makes a difference to what's going on? So I don't know what the easiest way to do that would be. It's not getting any traffic. It's okay. But one thing that's cool to see is that when you scale down the application, you'll see that the pods that are there will hit this state called terminating, and as soon as they start terminating, some other ones start up and start running again. So for now, I'm gonna go to our admin view. I'm gonna remove this auto scaler, and then have another look at our deployment, see how it's doing. But yeah, it shouldn't, I've done something incorrectly for it to automatically jump to 10. But I'm gonna go back and look at what we've done first to our resource limits. So going back up to our deployment, looking at our, looking back down at our line, CPU limits. It's possible that these limits are too low. I'll have to do some troubleshooting on that later. Last time I did it, we didn't have this problem. We do look at our autoscaler, which is removed, good. But it's still up at 10, so I'm gonna bring it down. 0, 1. Okay. Let that come back up. And I'm gonna monitor the load on our pod and see how much CPU usage is actually happening. And if we're able to see what the load is happening there, see what our resource limits are, and then from there we can set a level that we can control a little bit better, because I think it was too low before. Okay. And if I misconfigure it this time, then we'll move on to the next section. But now, actions. Let's put our pod scaler back with these new resource limits and see how we do. Also update that field to be the right. Instead of patient UI, it was rats. It's kind of long. See if I can. Node -s-2-i-OpenShift. Okay. Node -s-2-i-OpenShift. Okay. Okay, that went to the right deployment. We don't have 10 pods, we still have 1. That's good. That's good. Now that that's hanging out, okay, it's steady, fingers crossed. We should have our Cloud Shell up now. We're gonna copy that command from before to simulate a load on our cluster or on our application. Thank you, Evan. Let's grab that script that we had, which was an infinite loop. We go here, copy, paste, and then we need to get our app route, which we can get from got one pod running. Good. Copy link location. Let's get in here. And this is gonna write out to a text file. We'll say log.text because it's just gonna clog up our feed, and we're gonna put it in the background. All right, and we can make sure that that's actually running. Job 600, so yeah, it is. And we should see here on our Grafana in a second that update to the load. And I might get it started a few more times just so that we see it register a little bit there. Right now we don't have anything, but it's okay. I'm gonna run that last command a few more times. See what effect that has here in Grafana. Okay, so we got a little blip there. It's almost impossible to see, but it's there, I promise. How do I scroll over from this view? I can't, okay. Yes, thank you, Evan, for clarifying. Now that we have one pod running, we're trying to get the autoscaler to trigger. And I think that I set the resource limitations like too high this time just to make sure that we're not, it doesn't trigger accidentally. And now we're trying to create a load on the pods so that we do get a scale up, and we can watch where this load gets to, and we can set our threshold just under where that load is, so that when we set the autoscaler, it triggers at the point that we want it to. But this is something that you'll do with your own applications if you're trying to make sure that you're doing it correctly. You're gonna watch what your loads that you're getting in, watch the loads that you're getting in and see where your app is stable, and then set your threshold probably a little bit above that so that when you get hit with an influx and your load comes up higher, then we can figure out what's going on. So I just saw, okay, now it scaled up automatically to 10. I might have run that script too many times. I saw that all those pods just scaled automatically after I ran the script. So I can see what jobs they were, and I can maybe remove some of them. Let's see. 600 was the first one. Let's get rid of that one. 600. Okay, that one's gone, and we'll see if that made a difference. What I would like to see is like us drop down from 10. Like we went from 1 to 10, which doesn't really illustrate any sort of nuance between the levels. It's just like all the way up again. So let's figure out what's going on there. If I come back to my admin view, have a look at our workload, Yeah, right now it's up at 10. Let's look at our events. So about 2 minutes ago, it scaled up to 4. Up to 5, 7, 10, down to 8. So it has been scaling, we just haven't caught it. So as of 10 minutes ago, it went up to 8, then it went to 10, then down to 7, to 5, to 4, but we're back at 10 again. So this hasn't caught up yet to what's actually happening. We're still at 10. Let me remove some more of these processes. Let's say 725, I think that's one. Or yeah, 725, let's kill that one. 725. Okay. And then maybe one more for good measure, 739. And we'll see if we're able to see any nuance between the 0 and between 1 and 10. That would be great. I would love to show you that. But one other thing I could do as well is like mess with the resource limits. I thought that I set them exorbitantly high so that it wouldn't trigger, but apparently not high enough. So it looks like, looks like the pods themselves have a resource limit on them that is a lot lower than what the limit is on our autoscaler. So I'll have to figure out what's going on there. But this is essentially how an autoscaler would work if I didn't do it so hard the first time. I'm just gonna make a note to check that out. Okay, are there any questions about this before we move on to the next bit? Not from you. Okay, cool. And there's some really good documentation from about the autoscaler from Kubernetes. Kubernetes documentation is really good. I highly recommend checking it out. I'm gonna drop that there. But there are a lot of different things that you can configure about like how fast like the scaler works, you know, how much time it takes to spin them up and down. But we'll maybe have some more time to come back and look at this in a little bit. The last ditch attempt, I'm gonna get rid of some more and then see what happens. So we've got 728, 734, 745. 734 and 745. Oops. 745. Okay. All right. So we've got a few of them running now, and we should see the load come down on the pods as I'm deleting the processes that are hitting them with this loop. We can see our memory usage definitely tracking with us creating and destroying jobs. And let's see if our autoscaler will respond. If I just move it down one, if it brings it back up to 10. Oh yeah, it brings it back up to 10. We're still in that threshold. So yeah, I'll do some more work so that next time when we do this, we'll see it moving with a little bit more nuance. For now, we want to have a look at our health checks. So a little bit about how Kubernetes works. Let me get my Windows set back right again. Yeah, so for those of you following along in the Git book, we're at exercise 5 now. Excuse me, we have these two concepts of liveliness and readiness probes. So a probe is essentially a REST GET request, but there are different types of probes available. So liveliness probes let you know when you need to restart a container. Is your container up and healthy? And then a readiness probes is when it's ready to receive traffic, when it's prepared to do the work. So when we're talking about transitioning the loads, when we're talking about like having zero downtime, when I made that update for in the repo and saw the website change over to the new text that I put in, we wouldn't want our application to start pointing to that endpoint, pointing that pod to that endpoint until everything was set up and ready to go. And that's done with these liveliness and readiness probes. So when the readiness, when the pod is ready to go, then the traffic will switch over to that new pod and then it'll start taking down the old one. So if we want to create these liveliness and readiness probes, we're going to do that on this /info endpoint. So the info endpoint is what we were hitting before to get information about the patients that were in our example database there. And we can do that. So the first thing we're going to do is going to look at our deployment. So I'm going to jump back over to our, oh, that's our builds. Sorry. Let me look at our deployments. There we go. And we're going to have a look at where we would make that update. So let's edit our deployment. We're going to jump down to line 46 here, past all of this, past this resources bit. And then we're going to add our liveliness and readiness probes. Oh, wait. Containers line is 38. Yeah, that's where the containers are. Get our copiness, our copy right. Liveness probe. Copy that in. I'm gonna put that at this level. At this level. Liveness probe goes here. And our paste is still not working. I think it might be the browser that I'm using. So that wasn't the right place because it disappeared. We'll try again. Let's do it under. Let's try that. Not that exciting watching me wrangle some YAML. I do apologize. No, it's still not the right place. Oh, but it did put it. Oh, it did. It put it here. Right, there's our liveness probe. Great. So it's supposed to go at that level. All right. And then we'll get our readiness probe underneath. Liveness, readiness. Should be alive and ready just after this. Make a GET request at the path info on the port 8080. Save that. Okay. No, did not like that. Oh, because the object has been changed, I need to reload it now. Cut that part out. Reload. Okay. Now let's put that back. Here. Oops. Ready. It's not calculated. Liveness, readiness. Okay. Save. Whew. What did I do? Readiness probe. Oh, it's at the same level. This is a comedy of errors currently. I appreciate you all sticking around as I figure out what I have configured incorrectly here. Oh no, that's not right. I thought I found it. I didn't find it. Okay. If it doesn't work this time, then we'll have to press on, and I apologize. Okay, so you're saying that's in the wrong column, but the object has been modified. Apply your changes to the latest version. We did apply it to the latest version. Reload. Reload. This is the latest version. Yeah, if you can avoid YAML, I'm not going to say that. You can finish that on your own. Usually I work with a YAML linter in VS Code, and I probably should do that here. For now, let's, oh, interesting. There's something. Yeah. I broke something. That's what happened. Oh no. Let me take out. I broke it. I broke it. I broke it. The changes that I made were when the object got updated, I think it crashed the pods that were already running. I think I just told, yeah, I just told it that all the pods that I set up weren't ready to run. And so every time it crashed from me messing the YAML up, it crashed all the pods that were currently working. And so it was trying to spin up new pods at the same time as I'm making those edits. So I need to fix like two things. I'm taking copious notes about what I need to fix for next time. I think maybe we're gonna have to do part 2 again next week when I iron all these bugs out, and then it'll be so smooth that it'll be funny. Let's look at exercise 6 as well, before we're almost, because we're almost done here. One thing that that I did, so I did all of my deployments here from the OpenShift dashboard from the UI, but you have, again, you have the option to do all of this from the command line. And we want to make sure that you have some example of seeing that happen. So if you want to do that, so we can, in exercise 6, we have some Git commands that we can run here in our Cloud Shell. Excuse me, let me clear this out. Where we can clone our repo, and then we want to change directory into it. And this is our repository. No, this is a different repository. This is the build configuration for Node. Thank you for the encouragement, you all in the chat. It means a lot to me that you don't judge me for messing this up. So if you look at that repository, not the whole thing, not the Git clone bit, but that's the repository that we're working from now. There's a Docker file in that root directory. So that's our Docker file. And we're gonna go over to our OpenShift cluster. And if we click our name here, whatever comes up here, and we copy this login command, and I shouldn't be displaying this on the screen, but it's fine. It expires in 2 hours. So if you can get there in 2 hours, then it's all yours. I'm gonna grab this token and I'm gonna log into my cluster from the Cloud Shell. Great. So now we're logged into that same cluster that we had before. So this is my cluster that I have here. That is being a little finicky right now because I messed up the YAML. Actually, no, it's stabilized. After I pulled my YAML out, it looks like it's not complaining anymore. So yeah, I'm gonna debug the YAML and we'll figure it out. All right. Let's see. What am I trying to do? I lost my place. Oh, Cloud Shell, right. Now that we're logged in, we want to make a new project, which is done with a command OC new dash project. Oops, nope. Copies. There we go. Example health namespace. Okay, so there's a new there's a new project there, but there are no applications there yet. So we're gonna create a new build, and I want to go over this this command that we've got here. Let me bring it up to the top so it's clear. There we go. So we're creating a new build, and the strategy that we're using is Docker. We're gonna make a binary build from a Docker image, and our builder image is that node 10 one, the same one that we used before, and the name of our application will be example health. So that's what all of this is here. So we're doing a binary build from Docker. If it ain't broke, I can fix that. Yeah, right. I am terror on clusters. All right, so we've got our new builds and yeah, created an image stream with node and example health and a new build config called example health. And then we want to start our build. So we basically our build config is the instructions to make the build. And when we apply that configuration to create a build, we do that with the start build command. So we want to start our build example health from the directory where we are, and we're going to follow that build. Okay. Uploading. So the first thing that we did was create a new project. We got a namespace for this new project to go into. And if I jump over back to my cluster and I look at our projects, we'll see that second one. This is the one that we just did from the command line. So you can create them with this button here, the create project, or that OC new dash project. It would be the same as clicking this blue button here. And we can look at that how it's doing. Let's see. All right, I won't touch the YAML for fear of similar things happening. Getting some NPM warnings, that's okay. Building our container. Chicken. I will be a chicken today. That is fine with me. I've been called much worse. All right. I've written something with NPM that didn't warn me a bunch of stuff. Oh, we're good. So our push was successful. So the first thing that we did was created a new project. Then we created a build configuration for that project. Then we started the build, and now we need to deploy our application. So now we have an image that is our build. That's what we want, but we haven't actually deployed it to our cluster yet. So we're gonna do that now. And I'm gonna do that here. New app, example health. Okay, and now we need to expose the service for that so that we can hit it from the outside. And if you've worked with Kubernetes, you'll be familiar with that process. And then we want to get the routes. So this is the URL that's been set up for us. And then we want to go ahead and try to hit that. So, oops, copy. And you can see that this is a different repo because it says demo health. It's not the one that I had before. And if we go look at our project, yeah. If we go to our developer view, look at our topology, there's our application. Same as before, it was made from this deployment configuration. And there's the endpoint. So that's how we would do it from the command line if we weren't using the UI. If you were shelled into an OpenShift cluster, the steps are pretty straightforward for doing the same thing. And it follows the same process as you would do for Kubernetes, except that we're calling it a project instead of a namespace, you know, things like that. So we're at about time. Does anyone have any questions before I go back and figure out everything I've broken in 5?
Hey, Nigel, I just want to say that I was following along in that YAML, and based on the, the information in the exercise itself, and I was getting crashes too. So I don't know if there's anything you were doing wrong. Yeah, I think it's just maybe the instructions there in that exercise are wrong.
That's fair. That's fair. So I'll fix that. I know where the repo is. So when I figure out what's broken, then I'll make those changes. I don't want to blame anybody else first. I just assume that I made a mistake. I don't know who that was that said that, but thank you.
Sorry, yeah, this is Tim.
Tim, thank you, Tim.
No problem.
All right, cool. Well, I mean, it seems like everyone's chilling. Thanks to everybody that came out, stuck with us. I don't know. Yeah, hopefully. So I just want to recap again what we did get accomplished today. What wasn't broken was that we had another look at our metrics dashboards. We did our scaling, and I hit the scaler way too hard. And so next time I need to make sure that, make sure that I don't do that. And we saw it working a little bit. We saw like the processes in between of it going from 0 to 10, kind of. I'm gonna count that as a tie. It's not a win or a loss. And then after we got our autoscaler working a little bit, we talked about what liveness probes and readiness probes are. So if you get nothing else out of this, you know how those work. And you know that they do work because when I did them incorrectly and the application could no longer tell that our pods were live and ready to go, it just started deleting all of them because it said, hey, there's nothing working here. Like you told me this is what'll happen when it works, and I set that up incorrectly. And so by doing that, the application is following the instructions and saying it's broken. And that's the thing about how Kubernetes works. It's different from what we're used to doing, this whole like declarative versus imperative thing. If you've not heard it, a lot of people use it to describe how Kubernetes works. So we're used to doing imperative programming. We say implicitly, these are the steps that happens. First, you take this value, then you perform this operation, then you return this value. We have very clear instructions for how things are supposed to work. But the way the Kubernetes works is declarative in that you say, when my application is healthy, this is how it will look. And that's what our liveness probes and readiness probes are doing, saying when my application is healthy, these are the signs. And if it doesn't have those signs, then it does whatever it needs to do to make it happen. And we have some control over how it does that, but by and large, we're not saying, okay, we'll delete this specific pod, spin up a new pod. We don't have to get into the weeds with that. It just says it's not working. What do I need to do to get working? Whether it be creating pods, deleting pods, different operations that it takes to bring itself back to a healthy state. So when I misdefined a healthy state, then it was, you know, not having a good time with that. But that's what our liveness and readiness probes are meant to be doing. And then after that, we looked at how we would deploy the application from the CLI if we were shelled into our resources somewhere, if we didn't have access to our UI for some reason, or if you just prefer working from the command line. Perhaps you already have all of your YAML that works and you want to just apply all of your YAML from the command line instead of dealing with copying and pasting it into the UI, then working from the command line might be a good option for you. So that's pretty much everything that we covered today. And yeah, I'll have another, maybe that should be a workshop in and of itself, setting up like these liveness and readiness probes and, you know, seeing how things fail, doing a little bit of chaos engineering around OpenShift to see how resilient it is, as opposed to, you know, some other deployment strategies that we could choose instead of Kubernetes or OpenShift. So are there any questions or thoughts before we get on out of here? OpenShift troubleshooting meetup. Yeah, we'll do that. So yeah, good for now. Break it a few times first, and you may have questions. Yeah, I don't know how much I nominate literally anyone else. If I don't know how much time we're gonna have these clusters up. I think they should be good at least through today, probably for most of tomorrow before they take them down. So definitely do some experimentation while they're there. These clusters are extremely expensive to spin up, and the fact that they're doing it here for free for y'all is something to not take for granted. I will say, if you want to have some more experience with OpenShift, what I have a gist here. I think the link was posted earlier. I've got some helpful resources for working with OpenShift, for learning OpenShift, and Red Hat actually provide what they call the OpenShift Playground. Which gives you access to a cluster that is good for an hour. It comes down after an hour, but it will give you a chance to play around with deploying these applications. There are 2 other resources as well that are in the link that I want to point out. There's 2 books. So the Deploying to OpenShift and the OpenShift for Developers are 2 free ebooks. I have a hard copy of one of them. They're very good. Everything that I was talking about in most of the workshop is covered. And yeah, I've been through this a few times, got highlighted and dog-eared pages for the important things. But yeah, it's invaluable to see these two ebooks. And then I talked about the playground, and then the interactive learning portal that OpenShift has, which I can show you over here. Let me bring this over. Jen is sharing her screen. So yeah, the interactive learning portal, there's some other really good labs that you can work through. But yeah, otherwise, if you want to throw up my slide, I've got my email address there. If you have any specific questions you want to drop me an email, that would be okay. Nothing too major, but you know, whatever you need, let us know and we'll try to help you out. But thanks again for coming out. I don't know if Jenna wants to say anything before we head out.
Yes, thank you all very much for coming out. Thank you, Nigel. This was very helpful, very insightful. I know everybody learned a lot today. And I agree, we should have like a chaos session just somewhere peppered in to maybe in between or at the end of the series where we're just tackling all of the issues that people will encounter at some or could encounter at some point. This is Nigel's email, like you mentioned. If you have any questions, we will also be sending out follow-up email with all of the resources. All of the links have also been posted in the chat as well, but we will send them out as well again. But again, congratulations. This was your first time learning, doing an OpenShift workshop. You have completed the OpenShift 101 workshop series. You are now armed with the tools that you need to know enough about OpenShift to do what you need to do, maybe at work or on personal projects. Just for reference here, with the workshop slides that I'll be sending out, we have all of the workshop resources that we have also posted in the chat, as well as the OpenShift resources, including the Kubernetes documentation and the gist that Nigel created as well with more documentation for you all. And I also wanted to share how you can stay connected with us on social. So if you want to attend more sessions like this and other sessions as well, IBM Cloud, IBM Watson, machine learning, blockchain, we have a wide variety of topics that we cover. You can stay connected with us through our various meetup groups. We have Austin, New York, and San Francisco. You can also follow us on Twitter, Twitch, and on YouTube. And if you aren't already familiar with, we have our Call for Code challenge that we are still accepting some submissions for. So if you'd like to learn more about Call for Code, you can go to callforcode.org/challenge to learn more about our Call for Code challenge that we'll be accepting submissions for the next, I think for the next month or so through, yeah. So if you're interested in learning more, feel free to check out Call for Code there. I would like to thank our federated advocates, Evan and Tim, on the call that have been available providing dev support for the series yesterday and today. And I just want to thank Nigel again for a great series, giving us some great instruction and great leadership. And thank you all for coming, and we will give you updates and see you at the next event. So thank you all very much, and we are going to close out.
Thanks, folks.
So have a great weekend. Rest of your weekend. We will see you all next time. Feel free to check out the replay on YouTube as well.